Huh?
Hey, why so sad?
I have a fluid and I need to measure its biological properties, but I don't know what instrument to use.
It's okay. Let's watch my group's next video.
Okay, let's go.
Assalamu alaikum and a very good morning to our friends. Welcome back to Lex video 2099. Okay, so today we'll talk about rheometer, right? And we are from group 4. So before we look into what is rheometer, let's look what is rheology, right? Rheology, according to Strobel and G of 2001, rheology is defined as the study of flow behavior. So as we know, we have a few types of liquid or fluid, such as pseudoplastic, behemplastic, pseudoplastic, with yield, Newtonian, and dilatant. So it is normally applied to fluid materials, such as I said just now, and they all materials other than fluid, such which exhibit a time-dependent response to stress. So this rheology is typically measured using shear and the shear parameters such as stress and shear rate. Next, what is rheometer? Now we're gonna go to what is rheometer. Rheometer is a device or instrument used to measure the rheological properties of fluid, such as viscosity, elasticity, and flow behavior. And the main types of rheometer includes capillary rheometer and also rotational rheometer, as shown in the pictures below. Next, okay, so the principle of rheometer for rotational rheometer is when the sample between the two measuring elements, rotor and stator, okay, so you can see in the picture, is put in motion by dragging due to the rotation of the rotor. From the measurement of the torque and angular speed of the rotor, the shear stress and shear rate are obtained. As we know, the rheological properties can be measured when we obtain the shear stress and the shear rate, right? This ratio of the shear stress and shear rate will provide the materials and rheology properties, such as the one I mentioned just now. As shown in the picture, we have three types of rotational rheometer. Just now we seen the main rheometers, main types of rheometer. Now we see the types under the rotational rheometer. We have concentric cylinder rheometer, horn and plate rheometer, and also parallel plate rheometer. Next, let's look at the principle of rheometer for capillary rheometer. So when the pressure drop over the capillary, measured as the sample is pumped through. From thermodynamics, the shear stress directly relates to the pressure drop. Then the shear rate is determined based on the dimensions of the capillary and the flow rate of the sample. As you can see in the picture, right? We have a cylindrical geometry, and then in the end we have a capillary, which is a small place where the material or fluid will be pumped out. So this system of capillary rheometer is made by the Hagen-Poiseuille equation, as shown in the right side of the slide. We have the equation. So this system of the capillary rheometer, they apply this equation to find the rheological properties of the fluid.
So these are the main components of rheometer. At the top is optical encoder, followed by the motor, then the air bearing, and last is measuring system. Next, so what is the function of optical encoder? Optical encoder is only in the rotational rheometer. It provides feedback based on the interruption of light. So first, a beam of light emitted from an LED passes through a code disc, which is a transparent disc pattern with opaque lines. The light beam is picked up by a photodetector assembly, also called a photosensor. Then the photosensor responds to the light beam, producing a sinusoidal waveform, which is transformed into a square wave or pulse train. The pulse signal is simple. Light means on and no light means off. The pulse signal is then sent to the counter through the electronic board. The counter then sends the signal to produce the proper function, as in either stop, go, or rotate. The next component is air bearing. It also is in the rotational rheometer. It eliminates friction so that small sample deformations at low stress levels can be measured with minimal losses. The operation of air bearings relies on a sleeve and a shaft separated by a small gap, which is only 5 until 50 micrometer. High pressure is fed through holes in the sleeve into the gap, and under no load, the pressure in the gap is about half the supply pressure. When a radial load is applied, the gap on one side narrows, which increases the pressure and airflow resistance, while the gap on the opposite side widens and decreases the pressure. This pressure differential allows the bearing to support the load without metal-to-metal contact, even without shaft rotation. On to the next component, which is the motor. It is the main part which drives different tax fixtures. So in rotational rheometer, the motor drives the spindle or rotor which rotates within the sample. This controlled rotation is essential for applying shear forces to the material. The speed and direction of rotation can be precisely controlled to measure different shear rates and to analyze the material's response under varying conditions. While in capillary rheometer, the motor drives a piston or plunger that pushes the sample through a narrow capillary tube. This linear motion is crucial for creating flow within the material and for applying the necessary pressure to measure viscosity under high shear rates. Next is the measuring systems for rotational and capillary rheometers. They are designed to capture different types of data specific to the type of rheological testing each instrument performs. Among the measuring system for rotational rheometer is torque sensor. It measures the torque, which is rotational force, applied by the motor to the spindle or rotor. It is essential for determining shear stress, which is calculated from the torque and geometry of the measuring system. Next is rotational speed sensor. It measures the rotational speed of the spindle or rotor. It is used to calculate the shear rate, which is derived from the rotational speed and the geometry of the measuring system. Another measuring system is angular displacement sensor. It monitors the angular position of the rotating component and helps in determining the strain applied to the sample. The last is temperature control and sensor. It controls and measures the temperature of the sample. It is crucial for ensuring that rheological measurements are performed at consistent and controlled temperatures, as viscosity and other properties can be temperature dependent. So the first measuring system for capillary rheometer is pressure transducers. It measures the pressure drop across the capillary tube as the sample is extruded. It is also used to calculate shear stress. Next, volumetric flow rate sensor. It measures the flow rate of the sample as it is pushed through the capillary. Moving on to the temperature control sensor, the function is the same as in rotational rheometer, which is control and measure the temperature. And lastly is the piston position sensor. It monitors the position of the piston or plunger that drives the sample through the capillary.
Now let me introduce you all 5 common brands and models that exist in the market. Next slide. So the first widely known rheometer is Anthem Power, which is an Australian company. It is the most trusted rheometer series with more than 10,000 installations worldwide. Next. Where they have MCR series, and here the 2 examples and next slide. One of them is MCR7002E, which can be used for research purposes as polymers and plastic. And next. And second example is Rheolab QC, which is a compact rheometer used for quality control. And next, second brand is TA. Next, TA stands for thermal analysis, and TA Instrument is a US company where the world leaders in thermal analysis, rheology, and microcalorimetry. And here are the examples of the Discovery Hybrid Rheometer series. And next slide. Here is the Agres G2 Esther, which is the most advanced rotational rheometer for research and material development. And thirdly, next slide. The Malvern's Panalytical is a UK company that provides advanced measurements and material characterization, accelerating innovation and efficiency in R&D and manufacturing. They have KineNexus series and Rosen RH2000. And next, blend is aromatic Brockfield, which has been the world leader in viscosity measurements instrument for over 85 years. So the first DV next rheometers and RSO rheometers were launched in 2019 and RSX series was launched in 2021. And lastly, next slide, which is thermoscientific, is I'm sure that you all know about these blends, and it thermoscientific in also manufacture rheometer where they have Hacker Mass series and Hacker Visco Ester IQ rheometer. And now let's move to the next part. Where is the special feature of the rheometer? It can be vary based on their price range. So for raw price range rheometer, it is used for basic geology measurements and texture analysis. It is suitable for application use, small-scale research, and quality control. With its simple operabilities and minimal functionality, this is ideal for beginners and laboratory with limited budgets. While for medium price range rheometer, it is used for research and industrial applications that require higher precision and skill abilities and equipped with advanced technologies and functions to accommodate specific measurement conditions and property analysis. So the price range is suitable for use in mid to large scale laboratory and manufacturing industry. And rheometer at high price range are capable of fast and highly accurate measurements. It's suitable for specific high-risk tests and complex rheological analysis. So it is ideal for environments that require advanced analysis such as research and development of special material quality control in advanced industry and new product designs.
To the applications of rheometers. It is applied in different fields of studies based on their product, like in paint industries to evaluate dessert coating performance of the paints, then in pharmaceuticals to assess the viscosity and flow properties of pharmaceutical formulations, in food industries applied to evaluate the shear rate, viscosity to maintain the food texture, it will be the processing condition and the optimum product consistency, etc. Then in construction field to identify what is the behavior of the components like bitumen, asphalts over the time and how they will behave in different climates on the road. Then in biotechnology, to study the rheology of biological fluids such as blood and cell suspensions for medical diagnostics and treatment development. And lastly, in polymer engineering, to analyze rheological properties of polymers such as melt strength and dicer. We can see here summarized picture of some of the applications of these two rotational and capillary rheometers in different fields. So as we can see here from the left, some tests used in different colors. It's examined to see the formulation, filler, additives, etc. Then in the molecular studies to see the phase behavior, microstructure, etc. And other includes in the industries like processing, then product appearance, what is the particle suspending capability, what is the stability, how is the homogeneity of the product, and also the spreadability and product application, etc. And here is our references that we have used. Thank you.
Now, Krupa, do you know what instrument to use?
Yes, it's rheometer. Thank you.